Just a quick review of solids, liquids, and gases. Here we're looking at water in all three states. In the gas state, we call it steam. Liquid water, we just call water. And then when it's a solid, we call it ice. So if we look down at what the molecules are doing, in the gas state, we see that the water molecules are very far apart from each other. In a liquid state, they are touchingly close, and they are also touchingly close in the solid phase. What's different about the liquid versus the solid is the liquid molecules can slide around past each other, where in the solid state, the particles are like frozen, right? They're frozen in space. They can't move relative to each other. So, big difference between solids and liquids is the freedom of movement. So, in a liquid, the particles have enough thermal energy to overcome the attractions between them. You could think of the attractions between the molecules as them being sort of sticky to each other, like kind of Velcro things, right? Or, imagine the class and everyone's wearing a Velcro suit, right? And you try to squeeze past some people, and it's going to be hard, right? Because you're going to kind of stick to each other. In a liquid, the particles have enough kinetic energy, enough thermal kinetic energy, that they can break through, and they'll be forming and breaking these little intermolecular forces, but they've got enough energy that they can keep moving. In a solid, they don't have enough thermal energy, and they just get stuck to each other. Okay? Any questions about that? So these are, again, the different properties of liquids, solids, and gases. Gases will have an indefinite shape and volume. They take on the shape and the volume of their container. Liquids have indefinite shape, but the volume will stay the same. So you pour a liquid from one container to another, the shape changes, but the volume doesn't change. And solids just keep their shape and their volume. So liquids assume the shapes of their containers. Something special about gases is that they are compressible. Liquids and solids are not compressible. So if we have a liquid in this piston cylinder assembly and we push down on this piston, we cannot squeeze the particles any closer together because they are already touchingly close. If we have a gas and press down on this, there's a lot of empty space between the gas particles, and so we can squeeze them closer together. We can compress a gas.
Can you compress a gas into a liquid?
You can compress a gas into a liquid. Yep, absolutely. Not exactly sure why they throw this in here, but they do. Two kinds of solids, crystalline solids and amorphous solids. A crystalline solid is going to have a regular repeating three-dimensional structure to its particles, so they're going to be well ordered. Amorphous literally means without shape, and here the particles are just basically jumbled together. So this is a question that you should be able to answer. Which state of matter is compressible? Gas. So we are familiar with state changes. What we are most familiar with, I think, is state changes of water. So we think of the solid as being ice, right? So how do you make ice into liquid water? You heat it up, right? You melt it, right? So if we take a solid and we add heat to it, we can turn it into a liquid. If you take that liquid and cool it down, it will form a solid again, right? We take the liquid and we heat it up, we can cause it to evaporate. It may involve boiling or just evaporation. We can cause it to go into the gas state. If we take that gas and cool it down, it will condense into a liquid. The transition here between liquids and gases can also be facilitated by changes in pressure. If we reduce the pressure on a liquid, we can cause it to go into the gas state. If we take a gas and we compress it, we can squeeze it enough that the particles stick together and it becomes a liquid. So here's an example of a compressed liquid, a compressed gas. So propane is the main component of LP gas, which stands for liquefied petroleum gas. It's mostly propane. Propane is a gas at room temperature, but if you put it under a great deal of pressure, you can condense it into a liquid. This is a lot more convenient because now you get this large volume of gas in a smaller container. If you've ever purchased one of those little helium cylinders to fill up party balloons, you know that the helium in that cylinder will fill up balloons that have much higher volume than the cylinder itself because it was all squeezed together, right? So in this cylinder, there's a great deal of pressure, and so all of these molecules are forced to be close together as a liquid. But there will be some space up here, and some of these will evaporate into the gas state. When we open the valve and let some of this come out, it's the particles in the gas state that will come out and hopefully go through a tube into your grill and cook your hamburgers for you. And as these particles in the gas state leave, they are replaced as more of the liquid evaporates. Any questions? Yeah.
So like when you have gas in a canister like you're talking about,
Mhm.
I noticed some have propellants added to them, which are like, why do they add propellants to some?
So I think the reason there would be propellants is if you were trying to dispense a liquid,
Oh, okay.
like an
Oh, that's
aerosol
perfect.
can,
Okay.
right? That has a liquid in it, and they use gas propellants
To
to
spray it.
propel the liquid out, like spray paint or
Okay.
hairspray or something like that.
Trying to get a liquid out. Okay.
Yeah, but if it's just condensed gas, you don't need
You don't need a
anything.
propellant, okay.
No, it's a good question. Anybody else? Here's a molecular diagram of water. So we see the little Mickey Mouse head water molecules, right? And they're close together here. So this is liquid water. And the question here is, which of these diagrams, A, B, or C, would best show the vapor emitted from a pot of boiling water? So think about, well, what happens to the molecules when you take liquid water and you boil it? Do the molecules change? No, they just go into the gas state. This is a physical change. We learned that back in chapter 2. And so the individual particles do not change. So which of these diagrams is the best representation of boiled water? A. Because here we still have the water molecules. They are now just separated from each other in space.
You can tell Disney fans are hidden Mickeys in the water.
Pardon me?
You can tell Disney fans are hidden Mickeys in the water.
Yeah.